Okay, this is the atomic nuclear problem review. This is going to be the walkthrough for numbers 2 through 5. Okay, so let's go ahead and get started. So here we have an element with a half-life of 2 days, which means every 2 days half of that element will decay into something else. And we start with 40 grams, and they just want a time versus mass table. Showing how many grams of element X remain after each of the following number of days have passed. So here we go. So we're going to have time, and I always like to write time passed for you because it's the time that has gone by, or time that has passed, that you're looking at here. And then we're doing that up against mass. So this is our mass. And remember, you always start when no time has gone by. No time has passed. So when no time has gone past is when you have your starting amount of mass, 40 grams. Okay, so then one half-life goes by, 2 days, and our mass would get cut in half. And then another half-life would go by, which would put us at 4 days, and our mass would get cut in half. And then another 2 days, which is one half-life, goes by, and that would put us at 6 days, and our mass gets cut in half. And another 2 days, or one half-life, goes by, putting us at 8 days that have passed, and our mass gets cut in half again to 2.5. Another 2 days goes by, which is a half-life, and so now we're at 10 days, and our mass gets cut in half. And finally, one more half-life goes by, which puts us at 12 days, and our mass gets cut in half, and we end up with 0.625 grams of that element X remaining. Okay, that's number 2. Number 3. So we start with 10 grams of iodine 131. And we want to know how many remain after 32 days. They tell us the half-life of 131 is 8 days. So again, we want to start thinking about this as time that's passed versus our mass we have. So again, always start with 0 time. So 0 time has passed, and we start with 10 grams. And then 8 days go by, which is one half-life, and so our mass gets cut in half. And then another 8 days goes by, and that puts us at 16 days that have gone by, and we're at 2.5 as we cut in half again. Then another 8 days puts us at 24 days that have gone by, and that cuts us in half again to 1.25 grams. And then finally, one more half-life of 8 days goes by, which puts us at 32, which is how long they were asking about, and that cuts us at half again, which gives us our answer. So at 32 days, we would have 0.625 grams. Okay, so basically just the same thing as number 2. Okay, number 4. So this is the same as the other 2, so we'll set up the same. So we want to look at time that's passed, and we want to compare that to mass of the isotope. So to begin with, always 0 time has passed, and we have our original mass, which is 20 grams. And so now we just need our half-lives to go by. So 1600 years is one half-life. So that means at 1600 years we would have half, or 10, and then another 1600 years go by, and that puts us at 3200 years that have gone by. And we cut in half again to 5 grams. Another 1600 years go by, and that puts us at 4800. and that leaves us with 2.5 grams remaining. And then another 1,600 years go by, and that puts us at 6,400 years that have gone by, and we're down to 1.25 grams. And then another 1,600 years go by, and that puts us at 8,000 years that have passed, and we're at 0.625 grams remaining. And then finally we get to the year that we're looking at, which is 9,600 years that have gone by, and we get to 0.3125 grams. So 0.3125 grams remaining is our answer. On to number 5. Okay, now we have 14 grams of thorium-234 remain after 120 days. So now they've given us the end result. So we've got essentially the answer that we had and we were looking for in the other problems is what we're starting with in this one. Determine the mass of the original sample. Half-life of thorium is 24 days. So the first thing we need to do on this is figure out how many half-lives are going by. So we're just going to look at time that's passed, and we'll just start here and go 0 time has passed. 1 half-life would put us at 24 days, so that's 1 half-life. And then another 24 going by would put us at 48. It's 2 half-lives. Another 24 days or 1 half-life going by would put us at 72 days that have gone by. Another 24 days puts us at 96 days that have passed and 1 more half-life. And then finally another 24 days puts us at the 120 that we're interested in. 120 days right up here that we were looking at. So you can see 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives, 5 half-lives, right? So 5 times 24 days went by. So now we can look at, based on our half-lives, 2, 3, 4, 5, what happened to the mass in reverse. So in this case, since I know 5 half-lives went by, I know I end with 14 grams. Remember before we were cutting this in half. So if we're running a half-life problem backwards, we're not cutting the mass in half, we're doubling it. So this would go to 28 grams, and then it would go to 56 grams as we double it again, and then 112 grams, and then 224 grams, and finally up to 448 grams. So this is going to be your answer, 448 grams. And that's it. So if you have any questions, just make sure you ask in class. And that's it for this one.